Dear students, how are you? Hopefully you all are doing well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Let's have a look at our today's class. So dear students, according to our lesson plan, today we are going to discuss about chapter 3, that is complex number. To understanding the complex number, we have to understand first what does the physical expression of complex number, or why or in which expression we will actually talk about for the complex number. So if at the case of root over 9, I think you can tell me that what's the value of root over 9, and that's gonna be 3. If I am telling you, can you tell me what's the value of root over 81? Maybe you will tell me yes, it's 9. If root over 27, that should be, obviously you will think that it can be written as 3 into 9, so it can be written as root over 3, and this should be 3, so it can be written as 3 root over 3. But if I am telling you that what's the value of root over minus 81, or what's the value of root over minus 9, in these types of problem we'll start down, and maybe we'll telling that no, we have no solution about this, because we'll just think about the real field before today. This is the first time we'll talk about the complexity or the complex number, and in the complex number we'll actually dealing with these types of problem. And complex number generally made with some imaginary field. We'll discuss about imaginary field, but first of all, how we can solve these types of problem, or how or from where we can find these types of expression, first we'll find those part. Okay, so if we are telling you that can you solve the problem of x square plus 9 equals 0, then you may be telling that yes, x squared should be minus 9, then x should be root over minus 9, and from here we can do something, and that should be root over 9 into root over minus 1, since we can write minus 9 as 9 into minus 1, and from here we get 3 and root over minus 1. This is the part which actually denoted by I. So actually root over minus 9 is 3i. This is a complex part of the complex number. This is the complex part of the complex number. Generally we are telling it as imaginary part. Imaginary part. Here I is the imaginary part. Actually this has a history behind it, and these types of I has been coming some information. I will telling this according to the Eulers Theorem later. First of all, I wanted to share here root over minus 81 should be what. I think you can understand now how to calculate this part. It can be calculated by root over 81 into root over minus 1, so it should be 9i. So this is the part where we're dealing with these types of expression I, and we can denote this by telling a name of imaginary part which is I. Generally complex number has a standard shape, and the standard shape is looking like complex number. It's generally looking like a plus bi type, a plus bi type, and here a is the real part and b is the imaginary part. B is the imaginary part. So we can tell that complex number can be formed of two parts altogether. One is the real part and another is the imaginary part. So if any time we can say that real part and imaginary part are something, or are something whose combination is the complex number. So complex number is the mother number. From that number we can find real part and we also find the imaginary part, and both of these two parts are made with or consisting with the complex number. Clear? So this complex number definition can be like this. If a is 0, then we get the imaginary part. Since this imaginary part is pure imaginary part, since a equal to 0, that means 0 plus bi will get only bi, and if b is equals to 0, then this part will be 0, so we'll get a, and that is the real part, or the real part. So this is the pure imaginary part and this is the real part, and the combination of these two is actually the complex number. And maybe one question arises in your mind that I, in this I is the imaginary part and the imaginary field we are thinking about, and how we can denote in the dimensional part. Since we have already known that any point, say for example in the real point 2, 3 was the point, this point can be denoted in a figure, but can we actually, these types of complex number can be figured out in any shape? Obviously this can be shape, and the shape or the point can be denoted by a plane, and that should be like that. Here it is the, we have to think that this is the real part or the real line, and if this is the imaginary line, if this is the real line and this is the imaginary line, say for example when we are talking about this is a 0.23, on that time we were talking about this is the y-axis and that was the x-axis. It's really looking like that. And after doing this part, if we are considering a point at, the number, and the number is say for example imaginary, that is 3 plus 4i, can we figure out this complex number into this figure? How we can go for that? This can be done by 3, and that means 1, 2, 3, and 4i, that means 1, 2, 3, 4. So here is the part, so this is the part is known as 3 plus 4i. Similarly, we can also denote another line, say for example 7 plus 5i. How we can go for it? 7, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 5 we need actually. One, 2, 3, 4, 5. So this is the point where we can denote by this way. This is the actually point is 7 plus 5. Okay, in this types of problem, maybe you are thinking that okay, we are considering this is the y-axis or actually the imaginary field or imaginary line, and this is the real line, but why we actually going for 5 plus 7i by this way? Why this is like that? These types of question if you are thinking, then we have to go for a theorem named Eulers Theorem. Eulers Theorem says, so what we are talking about? We are talking about the Eulers Theorem. Actually, to understanding the Eulers Theorem, we have to think about the rotation. Okay, at the case of rotation, at the case of Eulers Theorem says if one is multiplying with a number, say for example a. Okay, one is multiplying such a number, that numbers make it at the rotate of 90 degree. So if this number rotate 1 as 90 degree, then it can be, we are thinking that a has been making 1 by 90 degree angle multiplying, and if we multiply the same number for the second time, then we'll get actually something like that. And after doing that, we'll get how 90 degree again. So this is the part which will be again rotate for the 90 degree. So according to the Eulers theorem says if one is rotated for the first 90 degree and the other number or the same number will be again rotated for the again 90 degree, then we get a number which is the same number back but a negative sign. Say for example, here this one, if we are thinking that this is the number line system, 1 has been rotating for what degree? Can you tell me? Here was first 90 degree and there is the another 90 degree. So 90 plus 90, that was 180 degree. So total 180 degree, if it converted here, then we get exactly -1, isn't it? Similarly, our Eulers theorem also telling us that if one has been rotated for the 2 times 90 degree and if the 90 degree is denoted by some numbers, then we get the same number back with the negative sign. So we'll get -1. And from here we can tell that a square equal -1. And a square equal -1, that means the value of a is root over -1. And this is the number which is actually I. So I think you can understand that I is something which make a number or make a number 90 degree rotated. Okay, so now we're talking about 7 plus 5i, why this point is there. So now we are thinking like 7 plus 5, this is the two number we are trying to just putting here. So 7, say for example 1 2 3 4 5 6 7, say for example this part with 7, and 5 1 2 3 4 5 5. So we are talking about that up to this part this is 7 and up to that part it is 5. So what actually happening here our this part was 7 and that part was 5, but this 5 has been multiplying by I, and I is something which make it rotate by 90 degree. Since this part has been rotated by 90 degree, that means 90 degree, so it will be actually converted it here. So that's why we are telling that this is the real part which we have find going for that part, and for the imaginary we will going upward. Why we will going for the upward? Because of multiplication of I. Clear? So that's why it is 7 plus 5i. So I think you can understand why a complex number we are denoting by this way. Okay, after understanding this part, now we are trying to focus on that if this is the conjugate number, then if this is the complex number, then what is the complex conjugate number is? Okay, what is the complex conjugate number is? The complex conjugate number should have been 7 minus 5i. So the imaginary parts sign should be sense. That is called complex conjugate number. Complex conjugate number. So if I am telling you, can you tell me what is the complex conjugate of a plus bi? Obviously you will telling us that a minus bi will be the complex conjugate. So we have thinking about the complex number clearly. Then we are trying to understand what is complex conjugate from here. Now we'll talk about what is the modulus of these types of conjugate numbers. Dear students, I have already telling you that a number, say for example 3 plus 4i, if I actually trying to actually denote this in the field of real and imaginary, that should be 1 2 3 1 2 3 4. Say for example 3 4. So in this way we'll get this part, and this is actually looking like a vector. And if this is a vector, then in these types of vector has actually two types of component. One is magnitude and another is the direction. So similar way, these types of complex number has the magnitude, and that magnitude is known as the modulus. So modulus is what? Modulus, we have already known that modulus is something which is generally known as like that. If it is positive, that it will be again a positive number. Actually, what is the modulus? That always it gives a positive value. Modulus is representing a distance. Modulus is representing a distance. That's why it is always positive. So what about the modulus of this complex number? Modulus of complex number, to understanding about the that here, if it is 3 4, that means up to that part this is 3, up to this part it is 4. If here actually creating 90-degree angle, so obviously this is the hypotenuse, and if we are trying to actually input here the Pythagoras theorem, then you can tell me very easily the hypotenuse should be root over 3 square plus 4 square, and the modulus is always that. Okay, so if I am telling you that what is the modulus of a plus bi, the modulus of a plus bi is equals to root over a square plus b square. So what is the modulus of 3 plus 4y? It is root over 3 square plus 4 square. So 9 plus 16, so 25, we get finally 5. So this is how we can find the modulus. So this is the main structure to find out any modulus of the complex number. So what's the formula? Just mind it, a plus bi equal root over a square plus bi. So if I am telling you what is the modulus of 8 plus 7i, do it. Very easy. Root over 8 square plus 7 square, 64 plus 49, you will get your answer after calculating. Now it's your two homework for you, that is tell me 15 plus 16i equal what? What's the modulus of this? What's the modulus of minus 4 plus 3i? What's the modulus of minus 3 plus 4i? Just finding this. Obviously you shouldn't have any thinking, any types of problem in here, because minus 4 no problem, minus 4 square plus 3 square you will get actually 5. If it is minus 3 plus 4y, it should be again minus 3 square plus 4 square, so it should be 9 plus 16, you will get again 5. So dear students, I think you can understand how to find out the modulus of any complex number. Here a very special thing we have been learning here, that is the negative part. We have always talked about the positive part. Now we'll talk about the negative part, because at the case of argument is nothing but the angle. Okay, what's the angle? Angle is generally known as the argument of the complex number. Now we are talking about argument. To understanding the argument, we also understanding the direction first. So dear students, we'll talk about argument obviously, but before that we are trying to actually figure out 4 figure at a time. Say for example 4 plus 3i, maybe its figure can be 4 3, so like that it is 4 plus 3i figure. Now if we are telling you that what's the figure of minus 4 plus 3i, that figure can be looking like minus 4 plus 3, so that should be the minus 4 plus 3i, because we know that minus 4 is this way 1 2 3 4, 1 2 3 4, and here 1 2 3, so we get that minus 4 3. If our part is minus 4 minus 3i, then where the figure will be there? The figure will be like minus 4, so 1 2 3 4, minus 3 1 2 3, so minus 4 minus 3 I will be there. And finally, where is the 4 minus 3i? 4 minus 3i, this figure can be looking like 4 1 2 3 4, 1 2 3 should be there, and this is actually 4 minus 3i. My dear students, why I am going for these 4 figures at a time? At the case of modulus, no problem in at all, because every time we'll get the modulus, the distance of it is 5. Okay, but if the distance of these are 5, but the problem is what will be the argument of this? Argument can be actually finding by 2 ways. One is anti-clockwise, another is clockwise. Where today, since that there is time limitation, we will only try to understand how to finding the argument by anti-clockwise system. Okay, so argument is nothing but the angle. Argument is nothing but the angle. So we are now talking about argument. So this argument telling us what is the angle which has been created with this line. Okay, so what's the angle of it? So if we denote this angle as theta, and if we just add this line and this line, we already know this is 4 and this is 3. But modulus only telling us what's the distance of 4 and 3. Say for example, one person has actually going from this part to there 4 meter, here to here 3 meter. So what's the distance he cover actually? We can find those types of problem by modulus. But at the case of argument, we will actually finding the angle between it. And angle is actually nothing but, since we have already telling us this is 90 degrees, so this is nothing but the base and height. So this is the base, this is the height, isn't it? So if this is base and this height, since this is the angle, so that must be height. So what about tan theta? Tan theta should be height of a base. So what about theta? Theta should be tan inverse 3/4. Here, very important thing, you should use the modulus in there. So this is the argument of this figure. But the problem is, when we are talking about this or that, on that time we face a very big problem. But try to understand that what we actually wanted to do. We actually finding the angle, and that angle must be supported from this line. So what's the angle in here? Since we are talking about anti-clockwise, so we are just trying to focus on that angle. So we can't actually directly find that angle, but we can find this angle by, first we find pi, and we are just trying to finding this angle first. And if we subtract from pi to that angle, we will get directly this angle. Okay, first we will finding the theta, and theta value should be always this. Theta's value should be always this. How? Okay, from here look at the figure very clearly. This is actually -4 and this is 3, but we can't say this is -4. Why? Because this is the just it just denote the direction or the distance cannot be negative. So we can say that tan theta equal 4/3. So here theta should be tan inverse 4/3. I have always telling you that theta always be tan inverse 3/4, but since this is minus, this is plus, so it is lie in the second quadrant, and we have a formula have been learned from the class 19 related that second quadrant part can be found by formula that is pi minus theta. Similarly, this is total pi, and if we subtract by this angle, then we'll get that angle. So the argument should be pi minus this part, tan inverse 4/3. Okay, so for the third quadrant, if we are trying to focus on to finding the value of this angle, then how we can solve it? We have solved these two by following the anti-clockwise, but here if we are thinking that we are trying to find the value of this by anti-clockwise, then the angle will be actually more than 90 degree or 180 degree. But at the case of argument, we have to have maintain a formula that is minus pi is less or equal argument of z or argument of something is less than or equal pi. So this limit says we can't go for this way, rather we have to think it by clockwise. So how we can find this angle anti-clockwise? In the clockwise part, actually it will be like that. So this total part is actually minus pi, since it is what? Clockwise. So here minus pi, if we subtract from minus pi to this angle, then we'll get actually the angle what we actually required from here. So for that reason, here the argument will be the value of theta, and that should be what? It should be actually minus pi. Will not go for that, actually pi, and then we'll use minus tan inverse. We have already known that our theta is tan inverse what? 3/4. So this angle is 3/4. So this should be actually minus pi plus tan inverse 3/4. So this is the value of the argument for this third quadrant system. If we find any value like -4, -3i or minus bi. And for the fourth quadrant, what we'll get? Actually, we need to find the value of this angle, and this angle definitely is just theta, and that should be actually argument should have been for this is theta equal minus tan inverse 3/4. So in a nutshell, we can say the argument will be found for something like 4 minus 3i, that is a minus bi type, will be minus tan inverse 3/4. Why minus? Because it is in the clockwise system. Okay, so now we'll see our next part from this topic. Very short time I am going to actually talk about power of I. Actually power of I, that means I 1 to the power 1 is obviously I, but if I square we have to think about, then I squared, that means actually root over -1 whole square, then we will get actually -1. If I to the power 3, then we get actually I square into I, that means -1 into I, that is minus I. And if we are talking about I to the power 4, that is I square into I square, -1 into -1, that is actually 1. These 4 are the very important part, because this will come just recurringly. So dear students, this was a little bit long lecture for you, but you can understand that I actually not finished today's lecture by very clearly, but obviously next lecture will be talking about the rest of the parts. Hopefully you have enjoyed the lecture, you have learned something from the lecture. Stay home, remain safe. Thank you very much.